the column types that we have available. As you can see, we've just been focusing on two different data types, which is integer and VARCHAR. There are way more that we might not even be able to cover all of them. So we'll just cover the important one. In MySQL, each column in a table must be assigned a data type, which defines the kind of data that can be stored in the column. Choosing the correct data type is crucial for your database performance and also storage efficiency and data integrity. So let's see the common data type that we have. We're talking about numerical data type now. We have what we call tiny int. From the word tiny int, it means this information is very small. Like the number of numeric information that you can capture is very small. And for me to give you the numbers, they are ranging from -28 to +127. So you can save information that has to do with inventory, count. So you need to be able to save something that is very small within that range. An example of that is like day of the week. Maybe you have a column that says what day did this person come to work, and you're having the option to choose 1 to 7. Obviously you should be looking at going for tiny int. So as a number, you should be able to hold negative information as a negative number and positive number. So of course we can insist that your data should only carry positive numbers, or it should be able to carry both signed and unsigned numbers. Signed numbers means positive and negative, meaning they have a sign attached to it. So if you say signed tiny, so it means it contains -127 to +128. If you then say unsigned tiny, that means it has only positive for 128, meaning if you put anything minus, it will not be able to accept it. So how do you specify that something is signed or not signed? It's actually very simple. So if this is our tiny int, remember there's a column that says signed or not signed here, which is unsigned, and that is on this section here as well. So you can actually check unsigned. So once you put a column as unsigned, what that means is that you cannot have negative value inside, it's only positive. And this is good for maybe some inventory, even though some inventory should allow minus. Maybe a place for age, somebody cannot have minus age. Something that has to do with positive value should be indicated that this only accepts information that has plus value. So it's very good for you to be explicit in telling your database what information they should be able to hold. So the next thing we have is small int. So small int ranging from plus or minus 32,000. That's the number of value that they can hold. Example of something like that is the population of a small company. Next one we have is medium integer. What are medium integer? It means mid-size integers. They range from -8 million to +8 million. Our infamous integer. So then we now have integer. So this area of in orderliness from smallest to the largest. Although integer is not the largest, it's second to the last. Integer can hold from -2 billion to +2 billion. Finally, we have big integer. They are actually large, crazy numbers. It's actually having, think, a length of 20 digits. So it's a very large number. An example of this is maybe you want to use to save the population of a country or the population of the world or something like that. And use it as also a primary key for a database that you know is going to be very large. So you can use big int to hold the primary key of a database that you know it's going to get very large. So let's go in the realm of precision, or in the realms of decimal. And the first thing we have is float. You guys know float, guys. So float is a single precision floating point, meaning that they are not really that too accurate. So it's approximate value with 7 digits of precision. What are the things that you can hold with it? So you can use it to hold maybe average rating of a product. You know that you are not really so concerned about the precise value that the rating should be. So imagine you do a survey and you want to get the rating of the performance of the product. People may enter 3.5, may enter 4, 5.5, like that. So imagine rating on an iPhone store, and then you see rating 3.5. So the precision is very low. They are not looking for exact 3.5777 something or something like that. So you use floating data type to hold things that are not having high precision value. Or then do you use to hold something that you need to be very, very concerned about? You use the next one, which is called double. Double has double precision floating point value. The approximate value within 15 digits of precision. So you can use this to, store precise scientific measurements. If you are really going for, exact, you don't want stories, so you can use decimal. So decimal allows you to hold more precise information. And we're going to get into the syntax of how to use all these things later down the line. So decimal allows you to hold exact value, defining precision, total digits, and scale digits after the decimal. Our decimal is written this way. If you wanted to create a new decimal data type, then you provide a value or bracket that allows you to put the length of what you are worrying about. So if you say you want something to be 20 digits, 5, what that means is that you need to be in 5 decimal place. The remaining 15 will be the whole number that should be there. Then the precision should be 5. Then the same thing can also happen to float. Remember, float should not be this large. Float majorly, in fact, I use float to handle something like percentage, like this. So this is equivalent to doing something like 100.43. So this is equivalent to something like this. Then decimal, you can do 10.5 or 4, can be 1, 2, 3, 4, 5, 6, 7, 8, 10, 7, 8, 9, 0. So notice that the total length is 10, and the 4 part is where the unit starts from. So you can use the same thing for double and the rest. So we only have three data type to manage anything that has to do with floating value or precision. So you can also do something like this: 1, 2, 3, 4, 5, 6, 7. The next thing is character or string. How do you hold string information? You've already seen a first expo here, which is Vakka. Vakka is a variable character, but before Vakka you have what I called character, and that's called CHAR. CHAR is what? A fixed length character string. The length is fixed, so you need to specify how long the data should hold. An example of it is to hold a country code. Country code, we know they're always in 2. Nigeria is NG, US is US, like that. So if you want to hold a country code, using character is very important, or is the default data type that you should use. So if you know the length or exact length of the data type that is coming into your database, character is the best approach for it. And that will take us to the next thing, which is Vakka. Vakka is if you don't know the length, but the length is within a sizable range, which is between 0 to 65,000. So it has range that you have to consider when you're putting your character. The next one we have is tiny text. So text is another thing, but we're starting with tiny text. Tiny text is small version of text. So tiny text is fixed to 255 character length. So most times, if you want to save something small and you know it's not going to be more than 255 character, you will use tiny text. Example address. But most times we default to using Vakka instead of tiny text. The next one we have is medium text. Medium text saves 16 million character. So this is also giving you a bandwidth. And you can't really specify the range just like the way you specify in Vakka. This one you are locked in. The same thing with tiny text. You are locked in what it is you are selecting here. And it's good for a long article or a blog post. Long text. Long text is very long information, like 4 billion character, I suppose. Yeah, it allows you to save 4 billion character. And finally, don't forget we have, even though for the fact that we have tiny text, medium text, it means, and we have long text, it means we should have text itself. So text finds itself in the middle, and that is also equivalent to your Vakka. Your Vakka has ability to hold 65,000 record. Text also have the ability to hold 65,000 record. The difference between text and Vakka is that Vakka is variable. You can adjust it to suit what you want. For text, long text, tiny text, they are fixed, having their own fixed value. So that's all we have on string data type. The next data type we have is date and time data type. Yes, you want to store date information of somebody, especially date of birth. That's one of the things that first comes to people's mind when you're thinking about dates. But there's a lot of things you want to do with dates. You want to know the date that maybe somebody approved the document, the date that someone created the record. So you'll be using dates a lot. What kind of dates do we have? You have date data type as it says, just called date itself. And what does it do? It allows you to hold dates without time, because there's dates on its own, just the date. Like today's date, if I say what's today's date, you tell me the date without telling me the time. So what if you want to capture the date and time? You now have what I call date time. So date time gives you the full information, the date and the current time that we're in. So the first example for date is to store someone's date of birth. Then date time can be used to store maybe when someone approved the document. Then moving on is timestamp. We also have timestamp as a data type. Timestamp are generally used to say when something changes in the database. Finally, we have time. Time is used to hold the current time, just like date. Date is used to hold date without time. Time is used to hold time without date. An example of that is to storing time of an event. Maybe you are creating content and then you have the column that specifies time. You are not concerned about the day, just the time, because it's possible that you might not want date specified, just one time. An example of that is if you have event application and then you say this event happens every Wednesday, then you now say a column that specifies time. So that column should be something like this, because it's time you're concerned about, not the days. You've already specified that it's happening every Wednesday. That's parts where you make use of the time data type. Okay, let's move on to binary data type. The binary data type in MySQL is used to store binary strings. There are different kinds of strings. There's the normal strings, which is more like character based. Then there's the binary type. Unlike character strings, like I just said, which stores textual information, binary strings store raw binary data and are treated as byte sequence rather than character sequence. So example of that is fixed length binary code of hashes. So now the next one after binary data type is we have var binary. So you might not be using the binary data type as it is directly, but you'll be using this column here to specify that the text should be, or the value should be sensitive and save the information as binary. That's the section we have here, this binary. So this one allows you to capture binary information, meaning that you can still use VARCHAR and benefit from the binary data type information that you have here, or you can just say that the data is binary altogether. So talking about binary, so this is var binary. Var binary is variable binary, meaning the length of the binary is variable. Blob are used to store pictures, videos, like encoded files. That's what blob are used to save. I will not recommend using or saving files, images, videos inside your database. We'll look at the techniques of saving pictures and images later in advanced classes. But for now, Blob are used to store images. You can actually save an image in a column in a database. You can literally save that, but it's not advisable to do so. So Blob also comes with tiny blob, medium blob, and long blob. So there are information that you might want to save. Maybe it's a very small GIF. You can save it inside tiny blob, or so maybe a passport or something like that. That is the data type that we have in this system. Note that you don't need to cram all these codes. All what you'll be doing will be handled from the GUI. You will use the GUI to create all these things yourself, but after you must have created it, we then need to now be able to query the database. That is what we'll be doing in the next class. So see you guys in the next class. Thank you for staying to the end. Don't forget to like, share, subscribe, and turn on the bell notification for more videos from us. See you in the next one.